Okay, we will actually go through question number 1. Okay, you should actually have this ready. Okay, now you see I have a group 2 metal M was added with hydrochloric acid, and they have mentioned to you that hydrochloric acid they are in excess. So I know that this is in excess. Okay, so first calculate the number of moles of hydrochloric acid. So this one is very simple. You just need to use N equals to CV over 1000. So C is going to be 1 times 40 divided by 1000. So you will get 4 times 10 negative 2 moles. Okay, that will be the answer over here. 4 times 10 negative 2 moles. Now, when the reaction had finished, the resulting solution was made up to 100 cm cube in volumetric flask. Yeah, I do understand. Okay, some of you said that, oh, if I actually finish this reaction, I am going to get HCl. I am going to get MCl2. So I do not know which one. Okay, if you have that problem, okay, do remember, just assume that both of them are in the volumetric flask. Okay, both of them are inside the volumetric flask, and then they are made to 100 cm cube. Earlier they were 40, but now they add water. Even though you add water to something, do remember the number of moles are going to be the same. Okay, do remember this. This one you are going to dilute further. It's like you can actually remember like this. If you have 10 koi fishes, 10 koi fish in a tank, and then you add more water, what will be the number of moles? It means number of koi is still going to be 10. So if you have a bigger tank with more water, the number of kois are still going to be the same. The same applies to the number of moles. So if you go and have 40 cm3 and then you add water only, okay, the number of moles are still going to be the same. So even though you like keep on adding to 1000 cm cube or something like that, the number of moles are still going to be the same. This is what we call as dilution. Dilution do not change the number of moles. Okay, dilution do not change number of moles, but they change only the concentration. Okay, the concentration only. So number of moles still remains the same. Okay, so here what they have done, they took, and let's say you're still confused, okay, ACl or MCl2, this information is going to help you to actually overcome that confusion. What is that? They say that out of this 100 cm cube that you have earlier, you are going to take 10 cm cube of the sample, and then you are going to react with sodium carbonate. Now, do remember, you need to think about between this ACl and MCl2, which one will react with sodium carbonate. This one is a giveaway. But let's say you still couldn't actually find out. They even actually help you over here. Write the equation for the complete reaction of sodium carbonate with hydrochloric acid. So they mean over here, they are going to ask you to ignore the MCl2. It means they are talking about HCl. Okay, so the one that is going to react with the HCl, yeah. So here the writing the equation, quite simple. Sodium carbonate Na2CO3. Okay, they say that this one is going to be a solution. Solution is aqueous plus HCl must be always aqueous. You are going to get NaCl plus CO2 plus H2O. And then if you want to balance, there's 2 there. I put 2 there. Okay, 2Cl, so I put 2 there. Hydrogen, there's 2. Carbon, there is 1. Oxygen got 3. Everything is balanced. Just put aqueous there. Gas, this one put liquid. Done. Okay, done. Now, some of you get confused when I put H2O as liquid, when I put them as gas. Now, if they are going to be heated, the tendency of actually water to be released is more towards steam. Then it's going to be gas. So in this case, even though this reaction is going to be exothermic, okay, we don't actually really have that much of heat. So we actually write it down as H2O in liquid form, even though it's actually 1 mark. Okay, take note. Okay, you need to actually write down the states. Very important. Okay. Now, calculate the number of moles of sodium carbonate. This is a giveaway also, yeah. Even you don't know the question, you can still calculate the number of moles of sodium carbonate. How? N equals to CV over 1000. C is going to be 0.05 times 15 divided by 1000. So Nevan, I need your help over here.
7.5 times 10 to the power of -4.
-4, yeah. So 7.5 times 10 to the power of -4 moles. Okay, calculate the number of moles of hydrochloric acid in 10 cm cube sample. Now, we know that it's 10 cm cube, doesn't matter, just refer to the equation over here. I know that, okay, you have the sodium carbonate is going to be 7.5 times 10 -4 over here. What do you expect over here? It's going to be the double. So you just need to times by 2. 2 times 7.5 times 10 -4. You will get 15 times 10 -4, which is 1.5 times 10 -3. 1.5 times 10 -3. Now, calculate the total number of moles, total, yeah, calculate the total number of moles remaining after reaction shown in equation 1. It means that we have calculated for 10 cm cube. After reaction 1, you need to actually go back to here, which is going to be the one that actually you change it to 100. It means you only took a small portion of that 100. Okay, you need to convert it back to 100. So like for example, if you have something and you took only small portion and that small portion is 1.5 times 10 to the power -3, you need to convert it to the full portion so that I know that what is going to be the total number of moles of ACl earlier, yeah, which is not reacting. So what I need to do is I need to times by 10. Okay, so I times by 10, so 1.5 times 10 -3 times by 10. I think this one, okay, a lot of people were asking me about this. So take note, it's always this kind of questions will appear, okay, and the numbers are always the same also. They will take 10 cm cube, then ask you to convert to 100 cm cube. They will take 25 cm cube, they will ask you to convert to 250 cm cube. So I've seen so many questions over the years. They only play around with these two numbers. Okay, take note, yeah. So it will be 10 to 100 or 25 to 250. So most of the time it's going to be times by 10. Okay, most of the time it's quite easy. Now, use your answers in A and B4 to calculate the number of hydrochloric acid that has reacted. Now, take note that the one that is not reacted is going to be 1.5. You already counted just now, okay? The remaining, yeah? So the remaining is 1.5, but I know earlier, I know HCl is 4 times 10 -2. So I can actually find out what is the one that reacted. So 4 times 10 -2, you just need to minus with 1.5 times 10 to the power of -2. And you will get 2.5 times 10 -2 moles. Use your answer over here, okay, and equation 1 to calculate the number of moles of M in 0.5 gram sample. So equation 1, okay, we know that now, okay, this one I have calculated, which is 2.5, yeah. So if I want what is this, that's going to be half of it, okay, half of it. So it's going to be half times 2.5 times 10 -2, I will get 1.25 times 10 -2 mole. So 1.25 times 10 -2 moles. And do remember it's 0.5 grams. So I want to find the AR. Number of moles is mass over AR. So the mass is 0.5. AR, okay, equals to 1.25 times 10 -2. If I'm correct, yeah, it's supposed to be, if you count, you will get 40. Okay, AR is going to be 40. And if you look at your periodic table, okay, you will get, okay, which one that has AR, which is 40, James? James?
Yes, sir. Why?
What is the identity of M? Look at your periodic table. Ella, can you help?
ZR
40, James. So if you look at the periodic table, the one that is 40 will be here. Can you see, James?
Yes, sir.
Okay, it's supposed to be calcium. Okay, calcium should be the answer. Okay, the identity is going to be calcium. So take note. Okay, overall is 9 marks, and now we will also see some other questions as well. Okay, this one I will stop recording.